Hello everyone, welcome to Data Discovery. In this channel, we will be seeing related to data science, data analysis part, all the AI tools, etc. things. So today we have came across the translation based project. So translation is based project is related to a NLP. NLP is called as a natural language processing. So by using a pre-trained model, a pre-trained model we used to get from the Hugging Face. So by using that, by using the API from the for the data set and for the model, I'm just doing a hyperparameter tuning, and I'm just going to train the model, and just we are going to play with it. So let's get started. So by the Google translation, if any word or any sentence we couldn't able to understand, we can use this Google translation and we will be doing it, right? So by that only we will make the project related to it, and we can run it in our own model. So definitely that will be super excited to do with it. So same thing, how it's happened, like English to French or English to any languages, it just translate. Okay, so we can give any language and it just translate any sentence, any word, or any type of the n number of sentence, like 10 to 15 sentence if we need to translate at a time, then also it will be able to support it. Okay, and the result will be also within a second we will be getting it. Okay, so based on that we will be doing one kind of the model. By using a pre-trained model we will be doing it, and then after we will be seeing the demo related to it. So let's get started. First we will just import all the necessary libraries. Okay, in which we are loading the data set. I will be giving a link also for the data set and for the model. You can use this link, and by using that we can download the data set over here, and we are using a TensorFlow. Okay, just check which version that you're using. It should be more than 2.0. Okay, and auto tokenizer, it's nothing but for a pre-trained model we will be using. So tokenizer helps in all the NLP based project. So whenever we are doing a model from end to end, at that moment we will be using a tokenization is nothing but the uh, at a time. Okay, if we are having a 10 sentence at a time, so what we will be doing, we will be distributing in a small pieces, right? We are distributing in a small pieces, and we will be training in such a way. So if we are having in one sentence, if I'm having a 10 words, then every sentence I will be concentrate which part is will be most important. Based on that I will be training, right? So based on in our case also, we are anyways we are using a pre-trained model. Still we used to have a tokenizer part in which it will be separated into small pieces, and we will be interested on it. Okay, and we will be dealing with it. So for that, before that, just install this pip install it. It has a several packages like dataset transformers, Hugging Face, Scrabble, etc. So just do it. But if you couldn't able to install it, anyways it's already installed, but if you couldn't able to install it, like if you need to upgrade your pip, so based on it it will be installing. At the first run I haven't able to install it, so I have upgraded my pip, and then after was doing it, so it's just updated once. Okay, and then after you will be getting this all type of the model: TFM, data collected from sequence to sequence, Adam weight decay, etc. So what is that? I have given a description related to it. We load the data set to the present link. Okay, from that you will be getting the from my notebook itself you will be getting the dataset link and the model link. Okay, use that dataset and model link at the description box in my GitHub link, you will be getting it. So first you need to load the dataset. I can show the dataset too. Okay, so this is how the data set present. So we have the training data set, testing and validation also. Training data set, testing data set, and validation. And for training data set, around this much rows, around validation around this, and the number of rows per presenting for each and every data set. So what usually happens is like from the data set, from the complete data set, we used to present as 80% of training, 80%, 20% of testing. Okay, we need to check that what ratio they have given for using the model training. But as per the data set, we will be giving 75-25 ratio, like that. So from that training we used to have some test for validation, for validating the data purpose. Okay, validating a model. So from the training data itself we used to split the data, okay, for validation purpose. And like that they have splitted the data, and you can see it over here. This is for training data set, and for testing you will be having this much. around 2.51k rows for validation for this rows. So they have given the sentence and they have converted it also. So this is nothing but English to Hindi translation from English language, yeah, for translating to Hindi we can use it. Okay, if you need to have a model for other languages or vice versa, apart from Hindi to English, for that also you will be getting a model from the Hugging Face itself. You can go with it. So once you have completed with the one of the project, you can hypertune with the other project also. Just you need to replace the data set and some part of the data you need to change it, and then after you will be getting it. So I'll just print one of the data once we have load the data from the raw. So we have named as raw data sets. Okay, I have present the train from the train. Okay, from this data set I am extracting only first row. So first row in English is present over here, and how they have translated into Hindi. So this is how we have stored the data. Second, then after we need to pre-process the data. As I've said, we need to tokenize. We need to separate into small pieces for while training. So for that, we have done the auto tokenizer. So when we are running this code, it takes a huge number of time. So if I need to say that I am using a pre-trained model only, but still it takes around 5 to 6 hours in my uh, at my PC, because I'm having a low GPU, low RAM. So because of that, it takes lots and lots time. So if you're having a good amount of RAM GPU, then it will be a very good thing. But if not, just wait. It will be training very slow. Okay, for that purpose, I couldn't able to run while I'm shooting the video. So then after we, it takes around 5 to 6 hours in my PC. So it differs from your PC. Now I have auto tokenizer, in which as I've said that it's stored in the format of dictionary. I think, yeah, it's stored in the format of dictionary. So English to Hindi. So for each and every word, there is one unique ID is present. Okay, so unique ID, we can say that in hello, it's a unique word, and it has the unique IDs also. So for each and every English and Hindi word, what in the from the sentence, whatever the tokenizer by separating into small word, so each and every present in, so, in a unique ID. So what is this attention mask? Attention mask is nothing but giving a attention for each and every word. So if for example, here around this much one is there, okay, like if some zero present in between, so it means that that particular word is not given so much of attention. But over here it's given attention to all of its words. So I have given a description for it. In input IDs represent the ID in which the specific letter is stored. Okay, and attention mask with values of 1 for all positions indicates that each position is attended to or considered when calculating the attention scores. An attention mask with value 0 for certain positions signifies that those positions should be ignored or masked during the attention calculation, in which that is not at all important. Without that also the sentence is formed perfectly for that purpose. So I have used so much of word, and I have tested whatever the unique ID is present and what the attention mask for the particular sentence, etc. things. So over here, so what is my target thing? So my target thing is from the pre-trained model. Okay, from the English word I need to translate to Hindi. So my Hindi is my target languages, right? In which that will be stored in the target tokenizer. Target means that I'm targeting, so that will be also separated into small pieces. So one sentence we couldn't able to learn it completely, we need to sort down into small pieces. So for that we used to have the tokenizer, right? So even that it's stored in a unique ID, and for each and every word the attention is given. So for that purpose we will be getting this one. Now what we will be doing is like, we will be getting one sentence and we need to translate to Hindi. English sentence should be translated to Hindi. So from the complete sentence that we are having, we will be we will be segregating to small pieces. So hello is different, this is a everything has a unique ID. And then after we will translating to Hindi. So what it will be doing, it will be mapping the unique ID of the English to the Hindi. So from the English letter, the English letter word has the unique ID, even the Hindi letter word also has unique ID. So for each and every letter, the word that we are giving, so it will be mapping with the Hindi, right? So based on that, we will be pre-processing our data. So first, this is a hyperparameter tune, that how much length, max input length is nothing but the English, and target length is nothing but Hindi. So in a sentence, we can, in a sentence or in a good 10 in a n number of sentence, we can take it around 128 letter word, we can give it at a time, and it will be translated. Okay. So like if we will be giving, if these we can give some other the examples also. At a time, if we will give more number of word, it will be get confused and it couldn't able to translate as our expectation. So we, this is a hyperparameter tune, so in which in our model, in our case, we can take it around 128 length word. Okay. And it can translate to a Hindi. So this is an hyperparameter tune that we can do it. So over here, what I'm doing, I'm just breaking down into a small word. There's the small pieces of the word from the sentence, and then after I'm taking a input as a separate, and my target as a separate. Input is nothing but English, and target is my Hindi. And then after I'm doing the tokenization techniques, and just I'm just taking the from the sentence, I'm just taking these small words. Okay, I'm taking a token of the words, and then after I'm just matching down the unique IDs between the English and the Hindi. Okay. Over here, I am having a, from this is raw data set, it's nothing but the actual data set. From that, the training data, I'm taking the last two rows. Okay. So over here, it has the unique ID. From this is my English one, and this is my label, that is nothing but my Hindi, this is my targeted ones. And the attention, you can see all one given, it means for each and every word it's giving attention. Okay. And then after I'm mapping down with the English and Hindi, so that's what is doing it over here. So as I have said, what is TF Auto model? I have represent over here. So TF Auto model, it's nothing but it's used for loading a pre-trained model. So the model that we are using is already pre-trained, right? It's already trained once, so that we are using it. So for that, this we need to use it. And the data connector is use nothing but it helps to preparing and formatting data for a training sequence to sequence model. So this is a sequence to sequence model project. Okay. And for any project that whatever we are doing with NLP, we need to give this batch size, learning rate, etc things. So learning rate should be more number of small, so less number of small, so it will take a small data. This is a part of a gradient descent. Anyways, I will be posting the video related to gradient descent, learning rate, etc things. Okay. Well, so before that, do like, share and subscribe so that you will getting at the notification itself. So whenever I'm uploading the new videos, so this is a hyperparameter tune. So if the model is not trained well, okay, while we are using it, so we can tune this values and we will be getting a good model. Okay. I will be using this in my model by preparing a model. Okay, I have used it over here. Batch size that I have declared it over here. Shuffle is equal to true, etc things. This is not only for my training, same it for validation, and same it for testing data also. Okay, I have fitted my model, that whatever the model that I have used, actually the model that I have given, I have generated now. So this is a well good model. I have seen the downloads. Whenever you're typing the model and data set, that whatever you needed, the top model that you are getting in the notification, the top model that you will be getting, it definitely good. You can see that how much people have downloaded it, how much people have liked it, etc things. So based on that, you can get the idea that this model is good, and you can, it's already trained well. Okay. So we have predicted model and we have saved the model over here. And then after, this is a demo. So actually I prepared it, but I couldn't able to do the video recording at that moment. So I have given one input letter in my English and in the English sentence, and then after I have set to for my target, that whatever that I'm doing for labeling that to Hindi. So I have translated it. So this is how I got it. So it's just a simple, but when we are training it completely from the scratch till end, it's not a very easy part. But by using a hugging face, it's very simple. Even for collecting a data is also not very simple. Okay, related to anything in NLP, not only for NLP, DL or ML problem statement also, more number of data we need to collect, but because of the hugging face we can get the data, we can get the model very easily, in which we can use the pre-trained model in our convenient, and we can hyperparameter tune in our convenient. So it's a very good platform. I will be giving a separate video that how you need to use this hugging face, what all things are there, the models, data sets, spaces, etc things, soon in my channel. So do like, share, and subscribe to the Data Discovery if you find it so useful. Thank you.